Hi everyone, let's look at the paper VELMA, which is Verbalization Embodiment of LLM Agents for Vision and Language Navigation in Street View. So this paper basically proposes VELMA, which is an embodied LLM agent which can predict the next actions of an agent given a prompt. And this prompt consists of the navigation task to navigate between two locations in the street view, as well as the prompt also consists of information from the agent's environment. So here is an example of the prompt. So you can see the navigation instructions here, and also based on what the environment of the agent is. You see certain instructions like there's a blue bench on your left, or some other landmark information in the prompt. And based on this, the language model predicts the next action, right? Whether it needs to turn around, go forward, go right, etc. And so they define their environment here. They use the touchdown environment, which basically consists of street view, around 30,000 street view, full panoramic images. And and the navigation graph, basically, right, to navigate from one location to another, consists of edges, right, which are associated. Each edge is between 2 points, two positions, v and v prime, and they are associated with alpha, which is the heading direction, right, in which direction the agent needs to move, for example. And this is a number between 0 and 360 degrees. And and the agent can either move forward, left, right, or stop. And based on the action which the agent takes and the current state of the agent, which is the current position, right, it can basically move to the next state, right? And the state basically consists of the current position of the agent as well as the heading direction. So here's an example of one of such images, right? Now let's say you want to move from node 1 to node 5. Then basically you would be heading in the forward, forward, right, and forward direction. And you would see at each node you have an alpha which is associated with it, which is the heading direction. So they use two data sets, touchdown and map to seek, which which basically consists of these navigation instances, right, where you have multiple instances of navigation trajectories. So here is a good view of what they try to accomplish here. So you have the prompt here, and the prompt initially has the description of the task here, as well as the navigation instructions, right? And so this prompt is fed into a model, either GPT-3 or 4, and to extract landmarks in the navigation instruction. So here, for example, the landmarks are Starbucks and a mail truck. And these large language models are able to do this if you give a bunch of examples. So they are able to learn in context and identify the landmarks. So you extract the landmarks which is associated with this instance, right? Here it is Starbucks or mail trucks. And then you pass this to a landmark scorer. So based on either the initial position or after the action has been taken, you have an environment, an image of the environment which the agent can see. This is part of the data set, right? And since it's a panoramic image, you have left view, right view, slightly right, ahead, etc. Right? So, so they use a landmark scorer module, right? So this basically has a model like CLIP, which is scoring the relevance or semantic similarity between the embeddings of the landmark, which is Starbucks or a mail truck, and each of these images, right? Left, right, or slightly right, and it comes up with a score for it, right? And anything which crosses this threshold basically says that you can assume that the landmark is in that image. And then you get a structured output saying Starbucks is associated with this right image. And then you pass that to your verbalizer, which basically verbalizes Starbucks is on your right. And also, when you look at the nodes, right, when you look at the number of edges from that particular position, you can find out if there are n-way intersections from the current position, right? And so this is how you summarize your environment in natural language. And then you provide this as part of your prompt. And then you prompt your language model with this. And then you basically wait for the next word prediction from the language model. And that basically corresponds to the action which the agent would take if it is in this environment. So they use a bunch of different and as discussed above, they use GPT-3 or 4 for the landmark extraction. They use CLIP for the landmark scorer here, and they use Llama or OPT or MPT as the language model generator, which is going to generate the next action. So here they evaluate a bunch of different metrics. One is a completion metric, which is how many times, whether or not the agent is able to reach the destination, the target location. The next metric is the shortest path distance metric, which basically measures the shortest path length between the location where the agent has stopped and the goal location. So we stop the prompting when the agent basically gives an action corresponding to stop, right? And if it hasn't reached the goal location based on the shortest path, you can get the shortest path distance. And then you also have the key point accuracy, which measures the ratio of correct decisions at key points. So for the task completion, basically a task is considered to be complete if the agent reaches the final destination or is one node short of reaching the final destination. And they use the language model, which generates these actions in both in context learning setting, just as well as they use it in the fine tuning setting. So in the few shot learning setting, they basically use two shot of the full prompt description or the text description, right? So these full text description would be this entire prompt sequence along with the actual action, right? So this is the goal truth. And then they prompt the model with the actual navigation task. And they also use it in the fine tuning setting where they fine tune models based on these instances, which basically consists of the goal path, right, between the source location and the destination location. So in fine tuning, they also explore this response based learning where instead of just feeding in the gold labels all the time, right? So for each action, you would need to predict the. So if you see this prompt is fed multiple times, right? In multiple time steps. At each point, the action which is predicted by the language model is appended to the prompt and then fed into the model again. So you can use this in two different ways. One way is irrespective of what the language model is predicting, you always feed the right action from your goal labels, right? That method is a teacher forcing method. Or you can also, and in that method, irrespective of what the language model predicts, you always start and go according to the goal path, and you don't veer away from it. So the other way is to actually just rely on what the language model is predicting, the student predictions, where you just use the predictions from the student and you continue generations. So here they use a combination of both the the teacher forcing and the student forcing, and they call this as response-based learning. And if you look at the results here, they find that this response-based learning performs well on the metrics we discussed earlier compared to just the fine-tuning with the gold labels. And in terms of in-context learning, the two-shot in-context learning, GPT-4 performs better than GPT-3, which is expected. Um, and then they look at different classes of models which they've evaluated, and they find that GPT-4 beats all of the others on both datasets, and GPT-3 is slightly better. Sorry, GPT-3 is better compared to the llama models, and the llama models are better compared to MPT and OPT models. And then they perform the image ablation, right? So if you remember, we have a landmark scorer, which gives information about the landmarks in the agent's environment. So they fine-tune the Llama 7B model using CLIP, using OpenClip, or a no image model. So if you don't have any image model, you are not really passing any landmark observation, right? And you can see that clearly not passing any landmark observation is not that good for all these three metrics. And passing landmark observations are better. And you can see that using open clip for the landmark scorer is better than using just clip. So yeah, in conclusion, they basically introduce VELMA, which is a large language model, and it's able to predict the next action of an agent. And it's continuously, iteratively queried with a text prompt that basically verbalizes the task description.